Watching your pet chicken preening and pecking at bugs in the backyard, it's hard to believe this docile creature is a distant cousin of the most infamous predator in Earth's history, the Tyrannosaurus rex. Molecular data recovered from fossils confirmed the dinosaur's avian lineage a few years ago, and Boise State geology lecturer Sam Matson is using the connection in a one-of-a-kind lab.
This class that we're doing this lab for is a historical geology class. We study Earth history, and one of the things we're doing this week is we're using dinosaur trackways to try to figure out how fast dinosaurs could run. And there's assumptions that go into that, and we're testing those assumptions using chickens and people. So we're using the size of the footprint and the distance between footprints to tell us how fast the dinosaurs could run, and we're verifying that with chickens, which are dinosaurs as it turns out.
After setting up a racetrack in the sand volleyball court outside Towers Hall on a rainy March morning, Matson unleashed 3 urban chickens, Ella, Dora, and Nicer, to walk and run the gauntlet in the service of scientific discovery. The biomechanics, physiology, and behavior of these birds provide clues about the same characteristics in other animals that walk on 2 legs, including some dinosaurs and people. Matson said the idea is to use what we do know to figure out what we don't know.
One of the cool things based on modern animals is that regardless of body size, animals move in generally the same way. And the thing that governs the length of their footprint, the length of their stride, is how fast they're going. So if you compare elephants and zebras and humans and chickens and cheetahs, ostriches, they all sort of behave the same way. So if we find that the students and the chickens behave like all these other animals that have been studied, then we can more safely assume that what we're doing for the dinosaur trackways is legitimate.
The distance between footprints left in the sand was measured at different speeds, and the students used iPod Touch devices issued through the university's new mobile learning program to enter in stride length, hip height, and foot size to calculate the details of locomotion.
The students are using iPods, which is part of the mobile learning program here at Boise State. It's an exploratory group on using mobile devices in the classroom. So that the data that the students are collecting, they can actually analyze while we're out here. We don't need a big computer lab and fancy software to do it. They can crunch those numbers and see if their results are valid before we leave. We've reconstructed a trackway, we've drawn it in sidewalk chalk right over here, and so the students are using their data from the chickens to infer from the trackway how fast those dinosaurs were probably going.
Matson said that the aim of the unique lab is to present the sometimes esoteric concepts of paleoecology in a dynamic context, deepening learning about Earth's history by bringing the past to life and making it real.
That's one of the things that I want these students to take away from the class, is that testing hypotheses and testing ideas is a big part of science. So we're verifying that whether or not those numbers that other people use actually work.